Hello everybody and welcome to today's webinar. Thank you for joining us today. As you know, the topic is going to be on analysing and troubleshooting Oracle parallel execution. Thank you again for those of you who logged in early. I do hope you've had a chance to check out the upcoming webinars. As you can see on the screen now, we've got one on the 22nd of May, which has been presented by Jonathan Lewis. This is quite a nice one. He'll be discussing built-in performance monitoring in Oracle and in SQL Server with a SQL Server MVP. So if you've been to any of the Oracle and SQL Server discussions that Jonathan has hosted, you'll know they're good sessions, so I would definitely recommend signing up and attending that one. And at the end of the month, we have a session on end-to-end metrics with Lassie Jensen from Oracle University. Again, please do check these out at redgate.com/oracle-webinars. There's more information about these two sessions. You get access to all of the past recordings as well. And there's obviously a link there to register for them. So today's main presenter is Randolf Geist. He's a member of the Oak Table Network and Oracle ACE Director, co-author of Expert Oracle Practices. He blogs at oracle-randolph at blogspot.com. It's got .co.uk up there because obviously I've copied it. The good thing about Blogspot, it does localize the URLs. Randolph will tell you a little bit more about himself when he does come online. As always, I'm James Murtagh, creator and editor of allthingsoracle.com. I work at Redgate, and you can follow me at Twitter at allthingsoracle. This webinar is brought to you by Redgate Software and the deployment suite for Oracle. We'll go over a little bit about Redgate and the deployment suite in a moment. As always, please do share what you're learning as the session progresses with the wider community. We'll get lots of people turning up, which is fantastic. A lot of people register as well, and obviously a lot of people come to the webinar section of the Redgate website to look at past webinars. But for anybody in your network that may not have heard it or missed it, please do let them know what Randolph's talking about. It's a very exciting session. I've got some suggestions if you're using Twitter for some hashtags. As always, everybody will be on mute for the duration of the event. Hopefully you can hear me nice and clearly. If at any time my sound goes or Randolph's sound goes, please do first check your own audio settings and let us know through the questions panel or through the chat panel. There will be a Q&A session at the end. As always, please do ask questions in advance, particularly as Randolph goes along certain bits and you want further information. Please do note that down, but we won't answer the questions until the end of the webinar, so please hang around for that. And a full recording of this session will be available, and I will send you an email with a link to where you can download that. So before we get going with the main presentation, for those of you who don't know about Redgate, I thought it would be a good idea to give you a little bit of information on what we do. For those of you that come to the sessions regularly, and thank you for if you do keep coming back, you've heard this before, but hopefully you've had a chance to check us out now. So Redgate, we're a tools vendor, so we produce tools which help Oracle developers and DBAs compare and deploy databases and to source control schemas as well. And actually, there's a nice little screenshot on the screen at the moment for a new product we've got, which is called Source Control for Oracle. And I'm going to be doing a live demonstration of this product at the end of the session. So if you do want to find out a little bit more about our Source Control product, or you're having difficulty source controlling database code at the moment, please do hang around. There will be a live demonstration. All of the Redgate tools fit into the deployment suite for Oracle. As I mentioned, the aim of this suite of tools is to make it much easier and much faster for you to compare databases, compare schema objects, table data, and to deploy those changes. You can find out more about the products at redgate.com/Oracle And as I've just mentioned, please do hang around after the main presentation to see source control for Oracle in action. One thing that sets Redgate apart from other tool vendors is we focus a lot of our efforts on helping the communities that we produce tooling for. So the webinar that you've attended today is just one of a number of things that I'm doing to help the community out. You can find out all about this at redgate.com/oracle-education, where you get access to upcoming webinars, to an archive of webinars. All of this content is free for you to download and to help you out at any time. I also, as I mentioned at the beginning, I'm the creator and editor of allthingsoracle.com. This is another free resource with a load of articles across a whole host of topics. I've got a screenshot of the All Things Oracle homepage as it currently stands. So I publish a lot of articles on there. One thing that is worth noting is this experts section there. Please do check out some of the people that are writing articles on, I guess, Redgate's behalf to help the community out and are presenting webinars as well. Okay, so that's enough of introduction, I think. I think it's time to get going with the main presentation, which is on analyzing and troubleshooting Oracle parallel execution. I'm going to hand over the screen and the mic to Randolph now. Please do bear with us as I do this. Hopefully it'll go smoothly. But as regular attendees know, sometimes it doesn't. But please hold on.
Okay, so I hope you can hear me, and I hope you can see my desktop. So this is Randolf Geist, or in the original German pronunciation, Randolf Geist. I'm an Oracle geek, and I spent a lot of time trying to understand how the Oracle engine works. And as part of that, I also try to understand how the Oracle SQL engine works, how the cost-based optimizer works, and with that knowledge I can usually troubleshoot almost any kind of SQL performance issue that you might encounter. I can also explain to you why that happened and what you might want to do in order to work around the problem. So as part of that, I also provide workshops where I explain all this stuff to you, starting from how to read and interpret execution plans, how the cost-based optimizer works, and depending on what you're trying to do, what kind of features of the database you might want to use, how to want to lay out your data, and stuff like that. Maybe even features that you might want not to use, that you might want to avoid, depending on what you're trying to do. So that is basically what I provide. So if interested, get in touch with me. Apart from that, I'm Oracle ACE Director, so I'm part of the Oracle ACE program. I'm also a member of the Oak Table, as already mentioned, and contributed to the Expert Oracle Practices book, which is now, I think, almost 3 years old, but still, I think, a recommended read. Right, today I want to talk about the parallel execution stuff, because I'm probably one of the few guys in the world that actually knows how this Oracle parallel execution stuff actually works, how to, for instance, how to read those parallel execution plans, and how you can troubleshoot that. The point with parallel execution is that it offers you some unique challenges that are simply not there if you do not use parallel execution. I will start with a short introduction, generic introduction, so that we can see what kind of additional challenges you will have with parallel execution that are not only applicable to Oracle, but in general to parallel execution, but then are also applicable to Oracle, of course. Then I will pick two major topics that I will talk about. today. Actually, I can talk for days about that stuff. I even offer a masterclass and a seminar about this parallel execution stuff. So this is only just an overview session so that you get an idea what additional things you have to consider when dealing with parallel execution. Right, so let's get started with the parallel execution introduction. Just to set the scene, what I'm talking about today is the Oracle Database Enterprise Edition feature that is called parallel execution, SQL parallel execution. In principle, you can tell Oracle, here is a SQL statement, please run it in parallel, and basically Oracle will take care of all the nitty-gritty details. And as we will see in a minute, there are actually a lot of nitty-gritty details that Oracle has to take care of. So that's a powerful feature that is fully integrated in the SQL execution engine as well as in the cost-based optimizer. So when the optimizer is searching for an efficient execution plan, it will also consider this parallel execution stuff if you tell them to do so. So the point is that with Oracle Parallel Execution, you basically have the capability that Oracle automatically spreads the processing of a single SQL statement execution across multiple worker processes, so that you have more than one process basically working on your SQL statement. But before we go into the details of how Oracle Parallel Execution works, let's first start with a very simple, generic parallel execution example. Let's assume you have the given task of computing the sum of eight numbers, and if you think about it, very likely, if you do that with a serial execution, you will use a rather simple approach that you basically take each number in turn and add it to the previous intermediate result, and then finally you will arrive at the end result. And if you think about this example here, then you can see that we are talking about 8 numbers, then this will probably take 7 computation steps, and if we assume that each computation step takes the same amount of time, then we could also say that this will probably take 7 time units. Now, here is an example how this could look like if we try to do that in parallel. The first thing that becomes obvious if we assume that we have a pool of workers available to us, that the first step is that we might have to search and find available workers. So that already adds kind of overhead, a startup overhead to the parallel execution stuff that you simply do not have with serial execution. And this actually applies to Oracle Parallel Execution as well, so it can take several seconds depending on what the exact circumstances look like. It can take several seconds until the Oracle Parallel Execution actually starts. And then the next step is, if you have found those workers that you want to use, then you as the coordinator have to instruct them, you have to tell them, you have to coordinate them, you have to communicate with them and tell them what they have to do. So that's again part of this possible startup cost that you have with parallel execution. So this instructing or coordinating of your workers. So that's one of the first things that becomes obvious. Then the next thing that becomes obvious, that it's quite interesting to see that in this case here, the approach to use parallel execution or to do something in parallel, you probably have to use a slightly different approach. In this case, we basically distribute pairs of numbers to each worker, and each worker then builds an intermediate sum. And this also means is one of these very important things to consider. If you want to employ parallel execution, then you need to be able to divide your task into suitable subtasks so that each worker can efficiently and independently from the other workers kept busy and can work on your problem. If you have a problem that for whatever reason, either due to implementation restrictions or simply because the problem cannot be split into suitable chunks, then if you have such a situation, such a problem, then it's very unlikely that you're going to benefit from parallel execution. And that's the same with Oracle Parallel Execution too. So I will show you some examples that simply probably won't bring you the benefit of parallel execution that you expect. Another important point is what you can tell from this example here, that in order to complete the task, the different workers have to communicate with each other. So you can see here, after building in the first step, building an intermediate result, they have to communicate with each other in order to continue the processing and build the next level of intermediate results until they arrive at the final result. And basically, you could also consider that after the final result has been computed, you need to return this result to the query, to the coordinator that was actually issuing the task. So what this means is that with parallel execution, you usually have to have a communication layer in place. And that's, again, also something that applies to Oracle parallel execution. There is a communication layer required, and this communication layer can also cause overhead. So this doesn't happen in zero time, this communication and redistribution of data that might be necessary in order to efficiently do the processing. So that's another topic that you have to consider, another challenge that you might have with parallel execution, that in fact you have to have communication in place, and that might take resources to have this communication in place. In fact, with Oracle parallel execution, you might have this situation that you have to exchange gigabytes or even terabytes of data between these worker processes, and that of course is something that takes time and takes resources, takes CPU resources, takes memory resources, so that's also something important to consider. Another thing that is obvious from this example here is that it's not that trivial to keep your workers, even if you have a problem that can be spread across these workers, even if you have such a problem that can be spread, it's not that trivial to keep your workers all the time busy. And that's another very important topic if you think about parallel execution. You can see here in the first step we have all 4 assigned workers busy, and then this communication step we still have all 4 workers busy, but in the next step already we only have 2 workers busy, and in the final step we only have a single worker busy. And that's another important topic that in particular applies to Oracle parallel execution too, that if you are not able to keep your workers busy all the time, if you have such a pattern where maybe in between only a couple of workers, or for a significant amount of time, only a couple of workers are actually working and the remaining ones are idle, then you won't benefit, you won't be able to reduce the actual runtime of your SQL execution in the way you might expect it. And that's one of the main topics that I will go into more details afterwards. But that's one very important point, and to my experience it's quite common that you might have issues with parallel execution. It might be one of the main reasons why parallel execution doesn't give you the runtime reduction that you might expect. Another interesting point that we can derive from this simple example here is that although I have employed 4 workers, and if you remember for the serial execution I assumed 7 time units, even if we omit here assume that the coordination and communication part happens in 0 time, we still have the best runtime that we can come up with is basically 3 time units. First time unit is this step here, and the second time unit this one, and the third time unit we arrive at the final result. Even if we do not consider the overhead of the startup and the communication, we end up with 3 time units. Now if you think about we employ 4 workers and we have 7 time units for the serial execution, it makes obvious that depending on what is happening with parallel execution, maybe due to the overhead and maybe due to the inherent overhead of parallel execution, or maybe due to the reason that you do not keep your workers busy all the time, you do not necessarily achieve an idle speed up. So execution might, even if you do everything right, the execution might not simply take a fourth of the serial execution time if you employ 4 workers. That's also something that is important to consider. And the last thing that I want to point out here is that if we include the communication steps, then you will notice that you actually have to work usually harder with parallel execution as with serial execution. So that's another very important point to consider. If you use parallel execution, then you usually, in order to achieve the same result, you usually work harder. So you throw actually more resources at the problem than with serial execution. And that's an important point, which basically means that you should carefully evaluate whether there are maybe maybe ways that you can solve your problem by working smarter rather than working harder. So parallel execution should be kind of a last resort thing, that if you are really, really sure this is a problem that makes sense to do with parallel execution, then you can make use of it, but you should carefully evaluate whether there are other options to work actually smarter. Right, so that's just a summary of the things that I just mentioned already. One thing I haven't mentioned yet, which is also very important, and that's one of the points I won't go into too much details in this session, is that of course the degree of parallelism, what is it called in Oracle usually, or the parallel degree, and so the principal number of workers that you assign to a task is of course also important. So the number of worker units assigned matters. If you have too few assigned, then very likely you won't achieve the reduction runtime that you assume, but too many can also be a problem. So arriving at the information, what is the optimal parallel degree for your parallel execution, that's also a very important topic, but I won't go into too much details of that today. So that's also something that I already mentioned. So it's important to understand that parallel execution is basically a brute force approach. So you do not work smarter. Actually, due to the overhead of parallel execution, you usually work harder. And therefore, what I want to focus on for today, because it's really a common issue and a serious issue, because it can influence the overall execution time of parallel execution significantly, is that with parallel execution you might actually have the problem that you do not work hard enough. As I've pointed out, you might have the problem that either you have a task that simply cannot be properly divided into subtasks, so you simply won't have the capability of having the tasks spread across your workers that are assigned, which I call here parallel unfriendly. I read this term recently on the blog by Alex Hotkelin, and I really like the term. That's why I used it here. So if you have a parallel unfriendly task, then you probably won't be able to benefit from parallel execution. And the other major challenge I want to talk about is the point that even if you have a task that can be divided into subtasks and therefore can be spread across workers, then you might still have the challenge that you do not keep your workers busy all the time. And again, this might significantly influence your speed up that you try to achieve with parallel execution, because parallel execution is basically about throwing as much resources at you as you think you need at a problem, hoping to be done quicker than with serial execution. It's, as I said, it's not really the smart way to work, it's the hard way to work. And this also means if you have this problem that possibly for whatever reason your workers are not really working, your parallel workers are not effectively working, you can end up with such a situation that only a few workers, or if you're in worst case only a single worker, has to do the majority of the work. You can actually end up with a situation where parallel execution is slower than serial execution, because as I pointed out, parallel execution also comes with overhead. So that's basically the worst case, and it's definitely possible to be slower with parallel execution than with serial execution. And usually the explanation in many cases is that if you have a comparable, for Oracle parallel execution, if you have a comparable execution plan between serial and parallel execution, then you might have a problem with keeping your workers busy. So there's a need how you can actually measure that, whether you have such a problem or not, in order to understand if there is something that you can optimize about the parallel execution. And that's also something that I will talk about. a bit today. So this measuring it, it's not that trivial. One important point with measuring whether you have your workers all busy or not. One thing important point to understand is that this measure actually doesn't tell you anything about the actual efficiency of your operation. So for Oracle parallel execution, this can, for instance, mean that you have a completely inefficient execution plan that might take ages to complete, but keep all your workers happily busy. So that's possible, and still doesn't mean that parallel execution will give you the runtime that you expect. But the other way around, if you have an otherwise efficient execution plan, but this execution plan for some reason doesn't keep your workers busy all the time, then you won't achieve that runtime reduction that you want to, that you expect maybe. And another important point, of course, that I won't go into too much details today is that even if you keep all your workers busy, if your system simply cannot scale the required resources, and since parallel execution quite often in SQL is about crunching big data, crunching through billions of rows, if you don't have all that data in memory and simply have a CPU-bound problem, but quite often you have an I/O-bound problem so that the data somehow has to come to the CPUs. If your system cannot deliver the data quick enough, then you might have a wonderful distribution of work among your workers, so all your workers are busy, but if all of your workers are waiting all the time for data, then again you probably won't achieve what you want to achieve with parallel execution. But even if you have a very powerful platform like an Exadata platform and employ parallel execution, if you have such a problem that your workers are not kept busy, then it doesn't matter how powerful your platform is, it doesn't matter how many CPUs you try to throw at the problem. If only one or a few of your workers are actually working, parallel execution won't give you the desired benefit, and that's one of the main things that I want to talk about. Right, and there are just some other specifics of parallel execution where you can have problems that do not give you the desired runtime reduction. One is that you can have these so-called parallel DML, DDL gotchas, so that's basically a homemade problem if you're not careful with the execution plans. Then one thing that can happen is a so-called downgrade at execution time, which simply means that although you maybe expect to have a certain number of workers assigned, you actually for some reason get less workers assigned, usually due to concurrent parallel execution. If you do not use a proper resource management, then it can very easily happen that you do not have the required number of workers available from this parallel worker pool. Oracle uses such a pool approach that you have these parallel servers, parallel workers in a pool, and if most of them are in use, then you won't be able to have the sufficient number of workers assigned, and this is then called the so-called parallel degree downgrade, which of course can also explain why your execution takes longer than expected. Then you have an inherent overhead of parallel execution that I already mentioned. You have startup, you have communication, but the implementation, the specific implementation of Oracle parallel execution also adds some specific overhead. But I won't go into too much details of that today. There is simply some things that you need to know if you want to troubleshoot that. That I explained, for instance, in this parallel execution masterclass. There are some implementation overhead that can add a significant overhead to the actual execution. And then there are simply implementation limitations that I will also show you one example of where Oracle cannot use parallel execution in the way you might expect it. So let's have a quick look at these parallel DML, DDL problems that you can run into. The crucial part to understand with Oracle parallel data manipulation and parallel data definition, which basically means create a table, for instance, in parallel, is that you quite often have basically two parts of that. There is a data manipulation part that can run in parallel, and you have a data acquisition part, a query part that can run in parallel. But both parts can also run in serial. And you have to be very careful that you get it right, that you basically end up with the desired execution plan that basically gives you either both parts in parallel or maybe only one part in parallel. So here's an example which you can end up with, which in most cases doesn't really make sense. This is an execution plan that shows you in the lower part the data acquisition part where a join happens, and this data acquisition part actually runs serially, so you do not see this parallel decoration stuff in this execution plan here. You can see these special PCWP stuff that basically means parallel worker combined with parent, and basically tells you this is running in parallel. So you have the data acquisition part running serially, and the data manipulation, the load part, that basically tries to insert data into a table, that runs in parallel, and that very likely in most cases doesn't make much sense, because these parallel workers here will probably be idle most of the time, waiting for input from this serial execution below here. So we have a single process that works on that stuff here, and we then distribute basically the data to these parallel workers, and that's probably something that doesn't make sense. You could argue maybe something like you have a high CPU requirement at that point here, which could be, for instance, some kind of compression that takes place. But usually this really doesn't make sense. You want to have in such cases both parts running in parallel, data acquisition and the data manipulation part. But it's possible, so you have to check the execution plan that you get. Here's the other way around. I have the data acquisition part that runs in parallel, and I have the load part that runs serially. Again, you can differentiate here that there is no decoration for parallel execution, and the load select is above this PX coordinator, above this query coordinator, which means this is done actually by the query coordinator. And this is an execution plan that actually might make sense in certain situations. For example, let's assume you crunch through billions of rows in order to produce a pre-aggregation for reporting. Then this might be something that might make sense, because you have to compute through billions of rows, but the aggregated step, the result of the aggregation might actually be far smaller, maybe only a couple of thousand rows. So there is no need to load a couple of thousand rows with parallel execution. That's something which the query coordinator can take care of. So there might be cases where this actually makes sense, but if you actually try to load billions of rows here, then you want to make sense. You want to make sure that the query coordinator, that the part that loads the data is not done by the query coordinator, but is done by parallel workers as well. So that's again something where you have to be quite careful. And just to give you a heads up that there are also sometimes strange limitations of Oracle parallel execution. If you come up with something like that, it looks actually like a parallel execution plan, but it's a typical implementation restriction of parallel execution. With Oracle parallel execution, you can end up with a plan like this. And if you look very carefully at this line, it says PX coordinator forced serial. And this is actually a serial execution plan in disguise, which means that at execution time, this will be done serially, although it looks like parallel execution. And this happens if you use PL/SQL, user-defined PL/SQL functions that are not enabled for parallel execution. Then depending on how you use these PL/SQL functions, this is one of the common cases where you end up with such a strange-looking execution plan, which looks like parallel execution, but in fact is not. So that's just one example where you have to be careful that there are implementation restrictions with parallel execution, where something like that can come up. So back to our two major challenges that I want to talk about today. One is this so-called parallel unfriendly case. So you might end up with a problem that cannot be really done in parallel, either due to implementation restrictions or because the problem simply cannot be really divided into subtasks. Here's a textbook case for such a thing. If you think about how the median is computed, so you have to find the middle value basically of all the values, then at least you can maybe understand how this execution plan here, why Oracle comes up with this execution plan here. If you look carefully here, it looks like parallel execution, so this table scan below here is done in parallel, but the actual grouping of the data is done by the query coordinator. And if you think now about that, maybe you try to find the median among billions of rows, then this billions of rows will be scanned in parallel by these parallel workers here, but only to send this billions of rows to the query coordinator, who's then the poor guy who has to do a sort group by operation and aggregation operation in order to find the middle value on all that data. So that is a textbook case that probably will not really benefit from parallel execution, although a part of it is run in parallel. So that's a very nice example where Oracle at least is not capable of coming up with a parallel-friendly execution plan. Here's another example of a parallel unfriendly case which looks like a parallel execution, is actually a parallel execution, but again we have a problem here in between. Basically we get the data, acquire the data in parallel, but then we have this row number function here, which basically tells Oracle I only want to load, in this case, 10 million rows from the table. But if you think about how row number works, Oracle basically has to go through some serial step where it assigns to each row unique increasing number, and this cannot be done in the parallel workers. That's something that Oracle has to do in a step where all of the data basically comes through, and that's basically what happens here. We scan the data in parallel, we even apply an optimization that Oracle knows I do not need to read more than 10 million rows in each parallel worker. That doesn't make sense at all, because that has to be sufficient in order to come up with a total of 10 million rows. But then basically all the data has to be piped through the query coordinator in order to apply the row number, and then will be spread again to parallel workers that will load the data. So we basically, if we pipe a significant amount of data through this query coordinator to this non-parallel part here, then we are in trouble. And again, this parallel execution is probably quite parallel unfriendly and won't give you the desired speed up. And another variation of the same problem, some analytic functions can cause you the same trouble. For example, if you think about the lag or a lead function, they have to identify the exact predecessor or successor row according to the analytic function definition. So whatever you specify as partition or order by, then Oracle has to find the exact row that is somewhere close to the other row according to your lag and lead that you define. And again, this is something that you cannot do independently in the parallel workers, because in worst case the successor or the predecessor row according to your analytic function might actually be processed somewhere in another parallel worker. So again, there has to be a point in the execution plan where all the data comes together in order to arrive at correct results. And that is again here this case in the middle where this where it takes place, that the data is piped through the coordinator process, and again this is probably then rather limited by the data that can be processed by this single process. So all these previous examples have one thing in common. If the non-parallel execution part has to perform a significant part of the overall processing, then very likely you won't get the benefit from parallel execution for runtime reduction that you expect. And that's something that you have to consider if you look at parallel execution plans in Oracle parallel execution. Then the other problem, even if you have a parallel friendly case, so things were fine in terms of that you can process it independently and without having to process it somewhere in the non-parallel part, then still it can happen to you that these workers are not really working all the time, so that they are not busy all the time. And then again, you will end up with a problem that parallel execution doesn't offer the speed up that you might think it can offer. If you think about this picture here, then basically this means we have here 4 workers assigned, and this is basically each column tells you a sample where we look at the activity of this parallel worker over time. So basically each box here might represent a second or something like that. For instance, if you think about in terms of this active session history information that you can get in Oracle. And ideally, if we took such samples for our parallel workers, then we would like to end up with a picture like that during the whole execution. So your parallel workers should stay busy all the time. That would be ideal in terms of how busy you keep your workers. As I said in the beginning, it doesn't really tell you something about the overall efficiency of the operation, but that at least tells you that all of your workers are busy. And again, you can see here the differentiation between CPU and wait activity. If we had here a majority of yellow boxes, which means that most of the time your parallel workers are waiting. So they are busy, but they're waiting for something to process, working for I/O usually, or waiting for data that should be sent by another parallel worker. Then again, although you have kept your workers busy, you probably won't achieve the desired runtime reduction. But that's the way we would like that it looks like. But something like this is a common issue with parallel execution. This is a data distribution problem. So in this case, we have the problem that the data is not evenly distributed among the parallel workers. So one of the workers or few of the workers have to do more work than the others, and there are reasons why things like that can happen. And then you basically end up with a picture like that. So you have some activity in those workers, but if you are unlucky, then the majority of the time or a significant amount of time you do not have all of your workers working, and then again it's very unlikely that parallel execution will give you the benefit. And there is another variation possible of that problem that is not the data distribution skew. This is the so-called temporal skew problem, which means that at the end, if you look at the total number of boxes, the total number of activity of each worker, we can see that each worker has probably worked a similar amount of time or had to work on a similar amount of data. But the problem is that we have significant idle time in between. So that is a variation, actually something that might pop up together with the data distribution skew case. So sometimes these two come together, or quite often they come together. So that's just a variation that has a different profile if you want to troubleshoot such an issue, because you cannot simply tell from the amount of data distributed to your parallel workers that you had a problem, which you can tell in this case here, because if you somehow can measure the amount of data that is distributed between the parallel workers, then in this case you can easily tell that something went wrong, that more data was sent to some of these parallel workers than to the others. Okay, so we have actually a problem with the potentially a problem with the way we keep our workers busy, and the tricky thing is that actually it's not that easy, at least in Oracle, to find out whether you have such a problem or not, to measure that so that you can see or easily identify that you have such a problem. You can think about the runtime. You might not be satisfied with the speed up that you achieve, but how do you know whether it's a problem with, for instance, which is also not unlikely in Oracle, that you end up with an inefficient execution plan, or whether you have a problem that the execution plan might be fine, but your parallel workers are simply not working hard enough. So in Oracle 11g, Oracle introduced the so-called real-time SQL monitoring feature, and that's actually something where my Oaktable fellow Doug Burns did recently a cool webinar here on allthingsoracle.com, where you can watch the recording, and also Oracle has a nice landing page for real-time SQL monitoring on their webpage, where you can get an idea what real-time SQL monitoring is actually about if you don't know what real-time SQL monitoring is. And with real-time SQL monitoring, you basically get a very detailed overview of a single SQL execution. So it provides you a wealth of information about a single SQL execution. And one of the things that it provides to you is also a very interesting information about the parallel execution work distribution. It requires, unfortunately, the diagnostic and tuning pack license, and if you do not have the diagnostics and tuning pack license, then you do not have access to that information. And to a large degree, the information that real-time SQL monitoring shows you is based on the so-called active session history feature of Oracle that has been massively extended with Oracle 11.1 and 11.2, so that a lot of more information is now recorded in this active session history, where each and every second all active sessions are sampled, and a lot of information is gathered about their activity. So the most important, or the best feature that you can use in order to understand whether you have such a problem with parallel execution, that you do not have all of your workers busy all the time, is this average active sessions graph. And I will show it to you in a minute. And you can also see the amount of time, the elapsed time, that each parallel worker was active in the database during the execution. So that's another point, another clue that you can see that maybe one or the other parallel worker was more active than the others. And then just let's have a quick look at such a real-time SQL monitoring report for parallel execution. You can see here that this parallel execution was using a so-called parallel degree of 32. And with parallel execution, in Oracle parallel execution, this means that you actually might end up with more than 32 workers working on it. Because for the majority of execution plans that are non-trivial, Oracle uses a so-called producer-consumer or consumer-producer model, which means that you end up with two sets of parallel execution workers. So in this case, for example, you might have end up with 64 parallel workers, so with two sets each 32 workers, and that is also something that you can see here then in this real-time SQL monitoring report. In fact, there are cases where you can end up with more parallel workers, even more than 64, but that might be some special cases. Just to give you an idea that a parallel degree of 32 in Oracle not necessarily means that you end up with 32 workers. You can end up with more workers. Then this here tells us that we actually have a so-called cross-instance parallel execution. If you have a rack environment with multiple nodes, so you have a cluster database, then multiple clusters can be involved, multiple nodes of the cluster can be involved in the execution, and this is called a cross-instance parallel execution, and that's just an example of such a thing, which again then gives you an idea that the communication overhead, for example, if you have a cross-instance parallel execution, then the data doesn't have to be shifted around in memory, it also has to be shifted around the so-called private interconnect, the network connection between the nodes, so that again adds even more overhead potentially to parallel execution if you have to shift gigabytes or terabytes of memory of data between those parallel workers. And as I said, the best information in order to find out whether you have such a problem with keeping your workers busy or not is this activity tab here. And this activity tab here gives you the easiest overview in order to understand whether you have such a problem or not. We can see here in the beginning of the execution, that is basically a timeline here. In the beginning of the execution, we can see the startup overhead. So it took a significant amount of time until the actual workers started working. That is the startup cost of parallel execution, which can happen and quite often happens. And then we can see another interesting effect that, as I said, we have more than 32 workers working. So in fact, although we have a parallel degree of 32, we have more than 32 average active sessions in that area here. So up to almost 60 workers were active at the same time, at least during some time of the execution. So which makes looking at averages and averaging the total execution time and the total active time of the parallel workers can make it tricky to understand whether you actually have a problem, because you could end up with something like this here, that half of the time you might have had 64 workers working, and the remaining time maybe you had only just one worker working, or just a few. And you can see here we have here definitely a problem with the how we kept our workers busy, because at that point in time something happened, and then for the remaining time definitely not all of our parallel workers were working. So there is something that can probably improve for this parallel execution. This might end up that we actually, it takes us less than this almost 2 minutes to complete this stuff if we somehow can manage to keep our workers busy. Another tab for parallel execution that you get from real-time SQL monitoring is this one here, where you see the amount of work, some figures about the amount of work that each parallel worker did. And we can see here, although it's not that visually obvious, that at least one of these workers worked a lot more than the others. So we can see here some time that these workers spend active time in the database, and it's quite similar for most of them, but here is one worker that definitely worked a lot more than the others. So that's another confirmation that something went wrong with the distribution of work among the parallel workers. Now the problem is also real-time SQL monitoring is cool for detecting such issues, so we can easily see this from this activity tab. Looking at that, we can see something went wrong here. If you look at this plan statistics tab, which is usually used on execution plan line level to understand where you might have problems with your, where you might have inefficiencies with your parallel execution. And one very rough guideline usually with real-time SQL monitoring is you have to focus on that part where the big stuff happens. Like here I have obviously used a lot of CPU here in this operation, so I should focus probably on those, because if I can reduce the work that is done there, then I might speed up my overall execution, and that is applicable to serial execution, and that is in particular also of course applicable to parallel execution. But with parallel execution I have the additional challenge that I actually might have the problem that I have operations that did not work enough, did not work hard enough. And that's the problem with that way real-time SQL monitoring here presents that information, that it's not very easy to find out which operations did actually cause the problem or were affected by the problem. But if you want to be able to address the problem, then you usually have to understand which parts of the execution plan are affected, which parts cause the problem, and then only you can systematically troubleshoot the issue. Otherwise you end up with basically trial and error in order to find out what you can change in order to address the issue. So there is a need for a systematic approach, and that is something that you do not get that easily from real-time SQL monitoring, at least not from the report that we look at present. And the problem here is that we can at least correlate something here. We can see the activity somewhere close to the middle of the execution, something happened. So we might be able to focus on some operations that started around the time. So these operations look like candidates, but these operations could also candidates on execution plan line level. But it's not really that simple to find out which of them caused the problem, which of them were affected by the problem. And that is one of the shortcomings with real-time SQL monitoring. If you have such a problem, you can spot very easily you have a problem, but it might be a bit hard to find out what you have to do then next in order to address the problem. Because there are certain things that you can do depending on what exact problem you diagnose. There are certain things that you can do about parallel execution in order to address the problem. Okay, so we do not have much time left, so let me just have a quick look at a similar execution. This is another real-time SQL monitoring report for this basically a similar statement. It's actually the same statement, but we can see here in this case that it actually took less time to complete. And if we in this case look at the activity tab, then we can easily see that in this case at least the distribution was okay. So we probably on average had at least these 32 parallel workers working. So we can also see from the parallel tab, if we look here at the parallel workers that are working, that we at least per set get a similar amount of time that they spend there. There are still some variations, but we do not have such an outlier like we had in the previous one. So in this case, it's visually obvious that it looks quite different from what we had in this case here. So it's quite nice and quite easy to spot the problem with Oracle real-time SQL monitoring, but it lacks a bit the information what you have to do next if you encounter such a problem, how you can approach the problem. So as I said, that's great. You can troubleshoot the first part of it for these cases where parallel execution doesn't work hard enough. You can address with real-time SQL monitoring, but you have the problem that it doesn't necessarily offer you the information how you systematically can then address the problem. Another issue with real-time SQL monitoring is that it might actually flush from memory. These reports, this monitoring information might be flushed from memory quite quickly. If you have a busy system, within several minutes the information might be gone, and at least up to version 11.2 this information is not persisted on disk. So you would need to have some kind of custom job or something like that that tries to persist that information. Otherwise, if you have problems that happened in the past, let's say a couple of hours ago or during the weekend and you come in on Monday, then very likely your real-time SQL monitoring reports are no longer available, and then you cannot simply click on that activity chart to understand whether you might have a problem, if you should troubleshoot some longer running batch job, whether you had a problem with the with this kind of work distribution. Now, if real-time SQL monitoring doesn't offer that information out of the box, what can you do then else in order to systematically analyze such issues? Funnily, in real-time SQL monitoring, there are some detailed information that are not part of the report, so they are not part of that flash-based report that I showed you. But you have to write custom queries on these GB $SQL plan monitor views, but then you can at least address some of these problems. In particular, this data distribution problem, if the data is not evenly distributed among the parallel workers. That's something that you can troubleshoot with a custom query, but only as long as this real-time SQL monitoring information is available. Then there are some other ways you can troubleshoot that, but they all have some severe drawbacks. All of them have in common that you need to reproduce the issues. So you have to run the statement in kind of under lab conditions, run the statement again, which can be a tedious and complicated task if you have to repeat a very large data load or something like that. And then you might have to somehow get the same data feed again. You have to have the same environment settings in order to get the same execution plan and so on. So it can be a tedious job to reproduce the issue, but all of these things like using extended SQL trace or using this v$pqtq stat view, which is a very special view, all of them have some severe issues. So finally, just to give you an idea, the active session history information, which is already used for this real-time SQL monitoring, is a quite terrific source for troubleshooting. And again, it can be used for also analyzing such distribution issues with parallel execution, in particular from version 11G on, where you have a relation in the active session history between the execution plan line, the execution plan operation, and the actual activity that was sampled. So you can do some very cool analysis based on active session history, in particular for parallel execution. Of course, you can troubleshoot almost any kind of issue, at least the starting point with active session history, because it's such a terrific feature. But in particular for parallel execution, you can do some cool analysis. And I've written a tool which is called XplanAsh, where you can use that active session history in order to do such analysis for parallel execution. And the cool thing about this XplanAsh tool is, and active session history, that you can do this analysis also for things that happened quite a while in the past. So for instance, you might be able to analyze something that happened a week ago, depending on the retention period of your so-called active workload repository, where also this active session history information is persisted. And XplanAsh can read that information from this active workload repository and can do some analysis for transient problems that happened in the past, which means that you can troubleshoot such problems without having to reproduce them, which saves you probably a lot of time. And what I did is I started a video tutorial on my blog with this latest release of that version. So in the next couple of days, I probably will publish that part that shows you how you can systematically troubleshoot such parallel execution issues. I won't not only show how you can do that with XplanAsh, but I will show you also the other methods that I quickly, briefly mentioned, this $PQTQ stuff, extended SQL tracing, or also real-time SQL monitoring, all that stuff, I will show you in that video tutorial. But in the meanwhile, we can already show these two parts that I've already published of the video tutorial, so that you get an idea what the tool is about. And as I said, coming soon is the next part then that shows you exactly this context. The tool can do more than just this parallel execution analysis, so there are more parts to come of this video tutorial that also can act as a general guideline for SQL execution troubleshooting. But I will do that one here first, this parallel execution stuff, so that for those that are interested and want to see all the nitty-gritty details and want to see this in action, how you can actually troubleshoot such an issue, so that you can watch this video tutorial. And finally, just to give you an idea, because it's much too much information if I would go into the details, just some ideas. If you can systematically analyze the issue, then you can do something about it. If you know what is going wrong, then you can apply some measures. And just to give you an idea, the things that you might have to do in order to address this data or work distribution issue is you can influence this parallel distribution by changing the estimates of the optimizer, for example, or you can explicitly influence that using the PQ distribute hint. So these are all things that you can do in order to address the problem, and it's also things that I teach in this parallel execution masterclass. Then you might be able to work around some problems if you use partitioning, if you have the license for that. There are so-called partition-wise operations possible in Oracle. So parallel execution can in turn make use of the partitioning option and can do some very efficient operations. It doesn't necessarily solve all of these problems, but it sometimes can be quite helpful to think about these partitioning stuff and do these partition-wise operations. And well, then there are of course other things. There are certain cases where you can only work around issues by really rewriting your queries, doing things in a different way, and ultimately there you might have to change your application design, your data, how you store the data in the database in order to work around these issues. But that then of course might mean a lot of effort in order to do that. Right, and I think I'm done with my presentation so far, so that we come to the Q&A section, and therefore I will now say over to James.
Hi Randolph, thank you, and thank you once again for going over the topic. We do have some questions in already. Thank you to everybody that has answered questions so far. If you do have something you'd like to ask Randolph, please do type that in your question panel now. So just give us a couple of seconds just to look over the questions, and then I'll start the Q&A. Okay, Randolph, so the first question, I know you can see that the question panel as well is to do with the overhead of running a lot of transactions. Is that something you could, it's quite a long question, so I'm wondering whether you could provide some helpful advice on a process on kind of a long time to process a large number of rows, and are there any issue if the statement is hinted to use parallel execution?
Yeah, I can see the question, James. Well, it's probably quite a broad topic, but what I can comment on is that if you try to do index scans in parallel, then you usually end up with, if you have to access the table also, or if your index is large, then you basically end up with a lot of random reads, which means that you do not have this sequential read that you usually have with full table scans, but you have random reads. And depending on your I/O subsystem, then this is something that might not scale as expected. So if you use normal rotating disks, then performing random reads is something that you cannot really scale very well. So in that case, it's definitely worth to check if the index scan operation really allows to scale. That is basically what I mentioned in the slides, where I said if you end up with your workers working, all working nicely all the time, but they're mostly waiting for I/O, then the actual speed up of execution won't be a lot, and therefore that's something that you have to consider. So most systems can actually scale much better throughput than random access. So a full table scan in parallel can be, for various reasons, more efficient than trying to run index scans in parallel. And there's also another point that these parallel workers in Oracle can do this true asynchronous I/O, which they can also do from 11G on when you do serial execution, but it doesn't necessarily happen with serial execution, whereas with parallel execution, unless you do this new in-memory parallel execution feature of 11.2, with parallel execution in Oracle you usually employ this asynchronous direct I/O, which bypasses a lot of overhead, and also, as I said, can do true asynchronous I/O. And this can actually speed up your full table scans a lot. And if your I/O system is capable of delivering the data fast enough, then you usually want to use a full table scan with parallel execution. There are, of course, always exceptions, but as I said, you might be able to scale random access better if you use largely SSD drives. But if you use normal rotating disks, then using index range scans and random table access might be a problem with parallel execution, that most of your workers are actually end up waiting for data.
Thanks, Randolph. There are a couple of questions have come in as you explain that, so you might want to just check those before we move on to the next question.
Yeah. There's a question regarding providing statistics and resources used, time spent for the inter-worker communication. Well, there are ways where you can basically measure the amount of data that is exchanged between the parallel workers. And for example, for real application clusters, you might also be able to measure the time that you have spent in the inter-node communication stuff. So there are ways that you can measure that, and in particular with real-time signal monitoring, you would possibly also see that you get sometimes certain kind of wait conditions recorded, that there was some kind of overhead with the communication.
Thanks, Randolph. Sorry, I wasn't particularly clear then. So there are some questions. If I'm starting at the top, it might be worth keeping your eye on some of the questions that come in at the end of the questions panel, because I think a few of those did refer to the last question.
Yeah.
So we've got a question here about, is there a way to query the SQL plan metadata so as to automatically reveal statements that lack parallelism? God, that's a hard one, on the DML side of the select side, or both? If not, do you think it's possible to write such a query?
Well, it's not something that I think it's easily possible. You could try to run some queries on the captured execution plans, but usually I think you should go more the way that you measure the runtime of certain certain processes that you want to ensure or want to make sure that they run as quickly as possible, and you want to use parallel execution, and if they take longer than you expect, then you basically should take a closer look at them. A general way to reveal statements that lack parallelism, that's probably not that easily possible. You could maybe come up with some query on the execution plan metadata, but that's probably not that trivial. At least I don't have such a query that I can provide.
Thank you. There's a question here regarding trace data. So the question is, how can I get 10104 trace from the slaves? I guess it might be also quite interesting to understand exactly what kind of data you can, or what kind of trace data you can actually get, and that would help you out here.
Well, actually, I would have to think about what the 10104 trace actually does. That's something I'm not sure off the top of my head. So therefore, I will first need to understand the trace information that in this case the question is about, in order to understand what the actual problem is that should be solved. So that's a trace that is not used that often. It rings a bell, but at the present, off the top of my head, I even don't know what the 10104 trace actually does. I could look it up, but maybe if the one who asked the question is still online, can just type in another question where it just says what he actually tries to solve by using this event trace, which then basically would write or emit some information to a trace file on the database server, and then you could analyze that trace file for further information. But off the top of my head, I even don't know what the 10104 is doing. I will probably remember it when I see it, but so off the top of my head, I don't know.
Thanks. So next question is, how could somebody identify whether they're having data distribution skew or temporal skew is happening in a session? What should they be looking at to determine this in terms of Oracle views?
Well, that is something that I've already covered. So if you have this, the best way to do that is the easiest way to do that is having this diagnostic and tuning pack license and running this real-time SQL monitoring stuff, so that you can see this visually in this active session graph, where you can see whether your workers were busy or not. That's the most straightforward way to see whether you have such a problem or not. And with this Xplan-Ash tool that I've mentioned briefly, you will see the same, basically based on active session history information. There are again various sections in the output report of Xplan-Ash where you can identify whether you have such a problem or not. So that's the most straightforward way, and that's also something, as I mentioned, that I will cover extensively in this video tutorial.
Great, thank you. The question here is, is there a rule of thumb for a number of workers compared to CPUs or cores?
Yeah, that is. I left that question out for a good reason, because that's on its own is a question I could probably would have to talk about quite lengthy in a quite lengthy manner in order to address it. In principle, you have to think about what kind of problem you're trying to ask. So it's something that you actually, if you want to do it right, you would have to do it on a per query or per SQL execution basis. So you would have to think about what amount of data I'm trying to process, what is my system capable of, what is the actual problem that I'm trying to solve. For example, if you have a problem that you know that is rather CPU bound, then this is something that you can quite easily reduce the runtime using parallel execution, provided that you get this data distribution or this work distribution right, and all of the parallel workers are working most of the time. Then this is something where you can basically throw as many CPUs at the problem as you want to. up to the number of CPUs or threads that you have available at your system if you want to consume all of your resources for this particular execution. But as I briefly mentioned, there are quite often problems that are more like limited by the I/O that you can put through your system, and therefore very likely you won't achieve much speed up if you increase the number of workers, because you probably only end up with a lot of workers that are simply waiting for the data to arrive, and therefore you don't necessarily achieve that speed up. And the point here is that a rule of thumb might be that you actually, if you really don't know what your statement is doing, you should actually start with a quite low degree of parallelism and then check whether you achieve more, if you achieve a significant speed up, if you increase the degree of parallelism. If you can test that somehow, then that would be one approach that you can use. But there are so many other things to consider, that you have an efficient execution plan so that you're not hindered actually in the execution because the actual execution plan is totally inefficient, and it probably doesn't matter how many resources you throw at the problem, it probably won't give you the desired execution time. So there are just really a lot of things to consider, and therefore the only simple rule of thumb is start with a rather low degree, except for the cases where you are very sure that you are mostly CPU bound, and then you can probably scale or reduce the runtime quite efficiently by using a higher parallel degree.
Thank you. So next question is, would you recommend disabling parallel execution for OLTP systems?
Yes, certainly. As I've already outlined, the parallel execution comes with some severe overhead, and it comes with some severe consequences for your system because it can consume a lot of resources. Therefore, it's something that you have to be very careful in a system that is mostly working on short-running statements like typical OLTP systems. Quite often there happens something like someone tries to rebuild an index somewhere over the weekend and uses this Oracle feature to rebuild an index in parallel, and therefore if you are not careful, then you end up with this index still marked as parallel, with some attribute that gets persisted in the data dictionary, and therefore after the rebuild of the index is complete, you might end up with parallel executions that you would like to see, because now the execution plan turns into parallel execution due to this index that's still marked as parallel. So, and that's usually causing much more trouble than it helps. So you should be very careful with parallel execution and OLTP systems.
Thank you. So an interesting question here. Apart from the ASH approach, what can be used to investigate issues on 10G, given that advanced SQL monitoring features appeared on 11G?
Yeah, in 10G, it depends on what you try to achieve. If you want to troubleshoot transient issues that happened in the past, then your best bet is the active session history approach. And since my Xplan ASH tool also supports pre-11G, you probably want then to have a look at this video tutorial where I show how you can use the Xplan ASH tool to troubleshoot such problems. And part of the functionality is also available in 10G, so you can at least, for instance, see those data distribution issues. You can clearly see with the ASH functionality of 10G, but only if you use either custom queries or if you use my Xplan ASH tool, which basically runs these custom queries on the active session history information. And the other approaches that are also applicable to 10G that I have briefly mentioned in the presentation, like you can, of course, use extended SQL trace. You can use these $PQTQ stat views, also a rather cumbersome name. This view can be used in 10G as well, and that's also something that I will show in this video tutorial.
Great, thank you. So the next question, Randolph, it's got quite a lot of information there. So it may be something you want to kind of pick a few bits out that you haven't covered already.
Yeah, I see. There are really a lot of questions that have popped up now. Let me quickly skim through the.
So thank you once again for everybody that has put your questions in. There are, whilst we'll let Randolph have a look at the questions, as you can imagine, as we go through the Q&A, sometimes we answer questions that have come in or that we have yet to answer. So just let Randolph have a look at some of the questions and see which ones can actually help expand on the topic of the presentation. There are a few questions, as always, in terms of the recording and the slides. The recording will be made available on the Redgate website. I'll also link to it from allthingsoracle.com as well. The great thing is if you go to allthingsoracle.com and you do have a question about the topic and about the video, you will be able to answer it using the comments function on the post there. So please do use that. I will put this all in the follow-up email that I'll send out as soon as I get the video up. Hopefully it should be up in a couple of days.
Yeah, just bear with me. I just have to see if I can pick some questions that I hope are more of general interest.
As I mentioned, I will be doing a demonstration of source control for Oracle. So once again, if you are interested in just having a look at this tool, or you're having problems with source control in database code, or maybe your current system or your current process is a little bit difficult and open to some errors, please do hang on, and I'll go over a quick demonstration of the source control for Oracle product.
I think one important point that I would like to comment on is because still a lot of questions are revolving around the parallel degree, the number of workers assigned, and so on. If you are interested in getting more information about how you can control this, and in particular how you can work with concurrent parallel execution, so if you have multiple queries or multiple processes running at the same time and each of them is supposed to employ parallel execution, then you can very quickly end up in a situation where you basically either overload your system or get this so-called parallel downgrade stuff where you do not get the desired number of workers assigned, and therefore things run much slower than you might expect. There is a very good blog, the data warehousing blog on the Oracle blogs page, and I have to check, I think in the let me just check I had a comment here on one of these my blog posts, and I have put together here in this, if you follow this free web, can you still see my desktop, by the way? Or have you?
So I can see your website. That's fine.
Oh, that's fine. Oh, great. All right. So in this free webinar post here, where I invited to this webinar today, I've put a comment where I've put together a lot of blog posts where Oracle, one of the Oracle guys, does really a great job of explaining all these details, how you can configure parallel execution, how you can use the resource manager, which is a very important tool if you want to seriously use parallel execution and concurrent parallel execution in particular, how you can use the latest features of Oracle parallel execution with the statement queuing and all that stuff, and you can really come up with very sophisticated setups in the resource manager, the database resource manager, can control all that stuff that basically allows you to control the resources that are used by parallel execution, so that no matter what parallel degree, for instance, if you have some power users that can run ad hoc queries on your system, so that no of your power users accidentally run a parallel with whatever number of parallel workers, so that your system is basically stuck. All these things can happen, but you can control them. You have to put in some effort in putting together a reasonable resource manager configuration, but in a number of these blog posts that I mentioned here in this comment, I give you a very detailed overview of what you can actually do with resource managing in Oracle with regards to parallel execution, and I highly recommend to anyone who is interested in getting more details about that by reading through this comment and then the links, follow the links and read through these, which also partially address this problem. What parallel degree am I supposed to use, or what can I do in order to control things that I do not end up with a situation where my system is overwhelmed by too many parallel workers trying to work at the same time. Then I see another question regarding what should you do with parallel execution and real application clusters. So in case you have multiple instances, a cluster database, Oracle cluster database, and what to do about it. It's again a question where I can only use the usual consultant advice. It depends. In particular, of course, you have to consider that, as I said, with real-time, with real application clusters, with a cluster database, you have the problem that the communication layer that you have with parallel execution might have to exchange a lot of data between the nodes if you're unlucky. So it really depends on how the execution plan looks like, and you might actually be able to get very good results with parallel execution that is cross-instance if you have CPU-bound problems, so that you can employ more CPUs that you have on a single node. So that is one case where you can get good results with parallel execution. But again, it really depends on what happens. You can also get good results if you can minimize the amount of data that needs to be redistributed, and in that sense you would need to look at the so-called partition-wise operations. So if you can do partition-wise operations, these at least to some degree allow you to avoid that data gets exchanged between the parallel workers, and then you might also get a really good scaling if you employ more than a single node. Also, it depends on what kind of nodes you have. I mean, with the smaller Exadata systems, you have each node is not that powerful. You only have a limited number of CPUs available. So in that case, it really might make sense to run cross-instance, simply because you are otherwise rather quickly CPU bound, because the Exadata, depending on your I/O rack configuration, whether it's a quarter full, half rack, whatever. If you have a big I/O subsystem in the Exadata, then you might really keep your CPUs busy quite easily with all the I/O that can be fed into the compute nodes, and therefore it might make sense to really employ cross-instance parallel execution if your nodes are not that powerful. Another question I might quickly address is this parallel degree policy auto, which means that there is a new feature in 11.2 where you Oracle can have determined the degree of parallelism automatically, and that is something that is also to some degree covered in these blog posts by the data warehousing blogs. that I've mentioned. So that's also something that you might want to read. And there is a certain, what you have to consider with the auto degree that Oracle determines, that it's based on the estimates of the optimizer. So it's not unlikely that if the work estimates of the optimizer are bad, so if the optimizer does under or overestimate the amount of work that has to be done, the automatic degree that is determined then is probably also unsuitable. And that's, of course, the nature of this feature, since it is based on an estimate. If the estimate is bad, the automatically chosen the degree of parallelism will also be very likely bad. So that's something we have to check then if you have a problem with the optimizer and the amount of work that the optimizer assumes has to be done. And there are some other knobs that you can turn for the automatic DOP feature, where you can basically influence how Oracle comes up with the degree. It's kind of a linear number that you can manipulate, the so-called I/O calibration number that you have to use in order to have this auto-DOP running. This resource I/O calibration stuff, you can read that up. And if you modify that number manually, you are able to influence the automatic degree that is determined. So these are the two things that you have to consider with the auto-DOP feature of Oracle, that the estimates, if the estimates are bad, then the auto-DOP will also probably be unreasonable, and also this configuration setting that determines the amount of I/O that your system is capable of processing. And these are the two things that you can use to influence the auto-DOP stuff. All right, so thanks. I think we are. I'm done with the questions that I would like to address, and then James.
Thank you, Randolph. So thank you everybody for putting the questions. I'm sorry if we weren't able to go into more detail on your particular questions. Once again, please do visit allthingsoracle.com. I will put a link in the presentation, in the follow-up email to this presentation. And I mean, Randolph will be able to pick those questions up there. Similarly, other members of the community might be able to help you out. Certainly have a number of rack experts as one example there as well. So, but thank you once again for everybody for joining us today. Please do take a look at the webinars coming up. So one on the 22nd of May and one on the 29th of May. As I mentioned, I am going to do a demo of source control for Oracle in a moment. Please do hang around if you'd like to check this out. But before I do that, I would like to thank Randolph for taking the time to present the topic today, and of course thank everybody for joining us for this.
Yeah, thanks. Bye.
So thank you for staying on the line for this demonstration. I will make it as quick as I can. Please just give me a couple of minutes just to get my machine over. So I'm just going to remote desktop into my one and bring it across. I'll do that very quickly. So before I get going with the the demonstration, I just wanted to give a quick outline of what I'll actually be going over. And I thought that an easy way to do that would be to use this diagram here. So what I'm going to be showing is the new product that's part of the deployment suite for Oracle that will make source controlling database code easy, very fast, and also enable you to have visibility over the changes that you're checking into source control before and after you've checked them in. The first example that I'm going to show will follow this diagram that we've got up on the screen here. So I'm going to make some changes in SQL Developer. You'll see that the product is a standalone product, so you don't need to be using SQL Developer necessarily. You could have teams using SQL Developer. Some of you could be using Toad. Some of you could be using Pure SQL Developer. Your team, you could be using all three of these different IDEs. What will happen as I make changes, source control for Oracle is going to pick up that there are differences between the database and my source control repository. It's going to highlight these changes on the taskbar, so I'll show you this. And then I'm going to be able to go into the tool, review the changes, and then check those changes in. So I've got source control for Oracle open already. I've already set up a source control project. So that's what you're seeing at the moment. So you're seeing that I've got a project name called Widget. It's linked to a database called Obstacle. The database called Obstacle is linked to my repository. You can see the URL there. And at the moment, everything's up to date. So what that means is that the database and the source control repository are in sync. So everything is the same there. So I just need to play around slightly with the screens just so that you can see a few things. Okay, so now I'm in SQL Developer, as you can see. I'm going to run a script to simulate making some changes, but you can see I've got a schema open, Widget James schema here, and I've got a table open, but I'm just going to run this script. So on the bottom of my screen here, you should see a number of icons, and one of the icons is for source control for Oracle. Because I've run that script, it's made some changes to the database, but obviously those changes are now out of sync with the changes that are in the source control repository, and source control for Oracle has picked that up. It's got a little red dot on here with an asterisk in it. I can right click and I can actually jump straight to that project. So remember at the beginning of the project that I said I'll be working on is this project called Widget, and this is the project that I've made changes to. So we click on that, we're going to go back to source control for Oracle. And we're going to go straight into the project screen. So you haven't seen the screen, but this is just one step from here. So if you remember, before this said that everything was up to date, but now we've got 5 changes that I've made to the database. It's telling me that I need to check these changes into source control. And these are the 5 changes. So we've got some tables, we've got a package, we've got a trigger, and a sequence. The great thing is, though, is that we've got a side-by-side diff view here of the database and the source control repository. So this top object is a new object, is a table here, and we can see that this is new. We're going to create this. This is the creation script. On the database, obviously there's nothing in source control because this is a brand new object that we haven't yet checked in. But we've got a couple of edits here as well, so we can see where the differences are, and it's highlighted the differences between the database and the source control repository. So for example, for this table here, we've added a new column, this discount number column. This is a new thing, and this is not included in this version of the table in source control. The great thing is we can scroll down and we can review all the changes as we go. We've got a couple of new things here. So we're always able to make sure that these are the right things that we want to check into source control. So let's check these in. We're going to type a log message. I'm actually using Subversion. I'll show you that in a moment when I come to the second part of this demonstration. But we could be using TFS as well. I'm just going to write a very short message. Obviously, you've got loads of space here to write a more detailed message. I'm just going to check those changes in. At the moment, all of the changes are selected, but we can choose individual changes to put in. The other great thing about source control for Oracle is it is looking at dependencies. So, for example, I've just clicked on this widget package to check this in on its own, and it's brought up a highlight saying that the object that I've selected references some other objects that I haven't selected. So I can select all of the objects that are dependent on those. So we've got these two objects here. I'm just going to select all of them, and I'm going to check them all in. So you can see, so the check-in was very fast. Now, normally, I guess what you'd be looking to do in your own system, if you're not using a tool like Source Control for Oracle, firstly you would need to script those objects out. Then you'd need to put them into Source Control manually. But as you can see, Source Control for Oracle has done all of that hard work for you. But it's also kept a history of these changes as well. And we can see here, this is the set of changes that I've just checked in. Again, we've got all of the objects. We can look at the side-by-side diff for all of these. And actually, if we look at this particular object, we can see that this looks a bit odd. So before, this was the package here, and the changes we made actually to this line, all we've done is we've put a minus and then a plus one. So we actually haven't changed it, but it's picked up that that is a change. We haven't changed the function of it rather, but we have changed the SQL. So it seems like a mistake, and I'm going to correct that in a moment. But with the history, we've got a full history here. So at the moment, we've got a lot of changes that I've put in that we can see here. But of course, I'm just one developer on a team, and there are other developers on my team as well. So for example, we've got Michael here, and we can look at the changes that he's put in. So when you've got multiple people working on the same database, making changes to the same schemas, you'll be able to get a history of the changes that they're checking in. Okay, so let's go back to SQL Developer. I'm just going to run another script here. Just going to make a few more changes. Of course, Source Control for Oracle is going to pick those new changes up. So just click on Done here, and again, we've picked up these two changes. And what we're looking at here, we're actually dropping a table, and we're going to correct that edit. So we can look at the side-by-side diff view again, and we can see that we're happy before we check those changes in. So let's just, again, just type a quick message in. Of course, advise that you put something a little bit more useful. So if you need to look back through the history, if you need to troubleshoot something that's gone wrong with your application, you're going to be able to do that, and you're going to have the comments here. And we're going to check those changes in. So I hope that gives you a quick overview of how you'd be using it if you're working in a team and you're all working on the same database. You're working on the same set of schemas. But you've noticed that I've actually only looked at 2 of the tabs out of the 3 tabs. So I've looked at the check-in tab and we've looked at the history tab. There's another tab here, which is the Get Latest tab. And this provides additional functionality if you're working in a distributed development environment, where maybe the developers have their own schema on the same database, a private schema on the same database, or they have their own local copy of the database itself. What I'm going to show you to highlight this feature is I'm actually going to imagine that we're looking to, that my team, we're looking to moving to a distributed setup. with my team member Michael. If you remember, he was also making changes to this schema. But I'm now going to populate a schema, his own private schema on the same database with all of the objects that I've been working on. We could have, of course, do this from the database itself, but if all of the team members have been checking their changes into source control, it makes sense that we should be populating Michael's schema, so the new member for the team, moving to a distributed environment. It makes sense that we should be populating this schema with the objects from source control. So that's what I'm going to do now. It will also highlight that if you are working in a distributed development environment, as one team member makes changes and checks them into source control, you'll be able to get those changes, apply them to the database before you work on the objects and before you check those changes in again. This will also enable me to show you how easy it is to actually set up a project. So we've already got this project here, so I'm going to create a new source control project. I'm going to connect to the same database. But this time it's Michael that's setting up a project here. As I mentioned before, I'm using Subversion, but you could use Team Foundation Server here as well. So it's all very easy. So at the moment, we've just connected to the database, connected the database to the repository, to the Subversion repository. Now I'm going to select the schema. This is the widget Michael schema. This is the folder that we've been working on. So it's an existing folder. You could create a new folder as well. It's unlikely, I guess, you'll create a new folder if you're first setting this tool up. As you're working along, as you're adding new projects, you're going to be likely to be using the same folder on the repository. So let's select this one here. We've got a quick summary. I'm going to keep this project called widget Michael so that you can distinguish it from the other project we're working on. And I'm going to create that project now. And you'll see a summary of both of these projects. So the first thing that you'll see is that it's come up that there's 14 changes to get. So if you remember before it was saying I had changes to check in, this time it's saying I've got changes to get. I'm actually going to quickly jump to SQL Developer because I want to show you the widget Michael schema here and to show you that it is entirely empty. So there's nothing in any of these. So no tables, no views, no index, no packages. But I'm going to populate it with the information that is in this widget James schema. But importantly, the up-to-date information, because there could be other team members that have made changes to these objects. I'm going to pull them out of source control and populate this schema. Once again, as I mentioned, this would be the same way as if you are already working in a distributed development environment and one of your team members makes changes. This is how you'll be able to get those changes before you work on the objects and before you then check your own changes into source control. So once again, we're able to review these changes. It's the other way around from what we saw before with the new objects going into source control, because this time we're taking the objects out of source control and we're going to put them into the database. So we can review all of these once again. Very quickly, I'm just going to click on Apply Selected Changes to the database, and now it's going to update that schema. So let's go back into SQL Developer. Let's refresh this and we can see now that all of these new objects have come in. Once again, importantly, these objects have come from source control. So that was a very quick overview of how source control for Oracle can help you out. So it enables easy database source control with SVN and TFS. It avoids human errors and removes manual processes to source controlling database code. It's a standalone application, so you can carry on using SQL Developer, Toad, Pure SQL Developer, or any number of combination or any different editors that you may use within your team. It also helps you to set up dedicated environments if you're looking to move to that way of development. It's an integral part of the deployment suite for Oracle, so it works alongside our other tools, Schema Compare for Oracle and Data Compare for Oracle. To find out more information, please go to redgate.com/source control for Oracle. If you notice there are some hyphens there in the URL, or you can just go to redgate.com/Oracle. You will see links to the product there. Please do check it out. You can download a 28-day trial. It's a fully functional trial, so you'll be able to install it and use all of the features and see whether it helps you out. I've got a few questions have come in already. If you are interested in me going over any more points for source control, please do type a question into the questions panel. Otherwise, please do check out the tool at redgate.com/Oracle, download a trial. We do offer full support as well, so we'll be able to get you up and running and help you out with it as well. Okay, so a couple of questions have come in. Please just give me a couple of seconds just to look over those and I'll answer those questions. If you do have any questions yourself, please do type these into the question panel now. Okay, so the first question is regarding auto scripts. So if we go back to the tool quickly. So quite rightly, we store the scripts as create statements and we show the differences as side-by-side creates. But when we change the live database, so when I pulled the changes from source control and updated the database for the last part of the demonstration, we run alters. Next question here, in terms of deploying changes from development to production, or I guess to test as well, the tool you would be using there would be our Schema Compare tool. So Schema Compare for Oracle will enable you to compare a scripts folder, and you can, if you was to check out your schema, you'd be able to use Schema Compare for Oracle to compare that against the test environment, and then use Schema Compare for Oracle to either deploy those changes or actually generate the scripts that you need to deploy those changes, and you can run those through your IDE. So the tool you need to use to make changes out of development to test, and again from test to production, would be Schema Compare for Oracle. Of course, that comes with the deployment. If you download the deployment suite, you will get source control for Oracle. You will get Schema Compare for Oracle as well. A follow-on question from that actually is a very good question in terms of automating deployments. The answer, we're here for continuous integration. There is a command line version of Schema Compare for Oracle, so you will be able to integrate Schema Compare for Oracle into your build system to do those to do the automated deployments. Again, the tool you're looking at there to help you for that side of it is Schema Compare for Oracle. in terms of support for other source control systems, so we currently support SVN and TFS. We've got a lot of feedback for other source control systems. As you can imagine, Git and Mercurial seems to be quite popular. Popular requests for further support. The more requests that we get in, and the more feedback, we'll certainly be looking at adding support for other source control systems. We are looking at ways that we can do that in the short term at the moment. The best way, I mean, if you go to redgate.com/Oracle, download the tool and let us know what support you need and what other features you need, and then we'll be able to add those to the list, and we'll be able to give you some feedback on when hopefully we can support those. A question here on reverting or rollback features. Once again, the product that you'd use for that would be Schema Compare for Oracle. If you download Source Control for Oracle, you will get a trial of Schema Compare alongside that, but in a similar way, you'll just be able to check out a specific revision to a folder on your machine and use Schema Compare for Oracle to create a deployment script from the database to this version. Oh, sorry, from the script folder to the database. So once again, please do check out redgate.com/Oracle and take a look at all of the tools that come within the deployment suite for Oracle. Question here, does Source Control for Oracle support versioning database grants? Yes, it does. The best way to look at the kind of number of objects that we support, if you go to redgate.com/Oracle, there is information there. I will include that in the follow-up email as well. Great. Well, thank you once again for staying on the line and looking at Source Control for Oracle. I hope that you found the demonstration useful. I hope it's a tool that you can see would help you and your team out. The only way to know that, I guess, is to download a demonstration, a trial version from our website. So please do that. I'd be really, really glad to hear your feedback on the tool. So please let me know how you get on. Once again, thank you for joining us today for the main presentation, and thank you for joining me for the demonstration of Source Control for Oracle. I hope you have a nice day or a nice evening, depending on where you are in the world, and I look forward to you joining me for the next session. Thank you.